I'm going to turn it over to the best-known Mark in the room. Please join me in welcoming Mark Hambleton.
If you're wondering, this is the design of the T-shirt for ARM. So, it says on the notes, introduce yourself. I figured that's probably a good start. My name is Mark Hambleton. I lead the open source software group in ARM's central engineering. I've been doing it for about 3.5 years. And I always assume when I do these things that most people might sort of know me, but I figure I'll just say, hello, good morning. So, today, I'd like to introduce you to a new trend that we're seeing, describe the what and the why, and some key attributes, but also explain why I think it's important to all of us. And hopefully, you'll start to understand why I'm getting quite excited about it and why I've been talking about it in many of the steering committees. Why am I going to talk about fog? Well, 20 years ago, I did a startup that got a good reaction from at least Cantor. That's actually taken from a TV show that two of us in this room, hopefully Ryan managed to make it in this morning. Oh, there we go. I'm expecting Ryan to go to sleep in 3 slides. But 20 years ago, I actually did a startup. That's actually the team. Now, we started working on moving core network services to the edge as part of the broadband revolution. It was becoming clear that the sort of things that we were trying to do with our internet connectivity weren't going to scale as we were connecting more and more devices. And yes, it was 20 years ago. We were talking about 1.5 megabits per second at best. This is actually an example of an edge compute system. It's the 19-inch rack thing in the corner. Yes, I am running Red Hat on the displays. I've since moved to Ubuntu. Sorry, John. Now, we've done the smartphone revolution. We're now securely backing up our photos, our contacts, everything about our lives into the cloud. We can now reinstall everything at the flick of a touchscreen. We're better connected than we've ever been through these terminals. And we're kind of doing the IoT revolution now, where we're collecting sensors and actuators to cloud services. And then use a portal in the cloud to control and monitor things about our lives. But IoT is getting more complex. These are some of the things that you could describe as an IoT device if you think about it. So I've got a connected car. Looks like George has got a connected car because he was showing us the output from his dash when he was looking at the versions of his kernel yesterday. But when we start connecting drones, when we start connecting all of the elements of a smart city, wind farms, electricity generation, et cetera, you're starting to talk about thousands of devices connecting to the internet. But actually, a lot of these devices, a lot of these collections of devices from smart cities, smart homes, smart factories, share a lot of the attributes of the autonomous vehicles. So when we think about a smart anything, it will most likely host multiple sensors of different types, control actuators of different types, connect to multiple cloud services for different purposes, require storage for local content caching, and compute resources to do stuff with that data. So actually, it's not really that different to what you think about when you think about an autonomous vehicle. So why isn't the endpoint to the cloud necessarily the right answer? Well, think of the smart light bulb. It's great when everything's working. But this is an example from Facebook I got from one of my friends back in the Symbian days. There you go, I got to say Symbian on stage again at another Lenara Connect. basically, the system that he was using defaulted to on when the power went out and then came back up. No internet connectivity. Basically, all of the lights in his house came on full blast. I believe he also removed all of the light switches. Why do you need them when you've got a smart home? But imagine that happening in your autonomous vehicle if it was completely reliant on cloud services to give it its indications of what to do. It's not going to work, is it? So you need to start thinking about how you push more and more processing and intelligence towards the edge. But also, when you think about things like autonomous vehicles, think about the connectivity challenges that you have on a day-to-day basis. I live on the outskirts of London, 12 miles from Heathrow, and I regularly go to Heathrow, as we probably know. I can't actually have a phone call in the car as it takes me to Heathrow. The phone will drop at least twice. That's obviously not acceptable when you've got a complex machine trying to do something. And so when you think about it, the number of devices that we're connecting to these cloud services is increasing exponentially. The data requirements of those cloud services is increasing exponentially. Latency is critical to a lot of the things that we're doing, to many of these new applications. And that doesn't scale, even with all of the new connectivity technologies. So something's got to change. So the trend I'm talking about is pushing data center services to the edge, which we referred to as either edge computing or the fog. We're building compute, storage, connectivity, control, and decision-making into these clusters of devices much closer to the edge, in between the cloud and the local network, to enable local processing and decisions for latency-sensitive services when that cloud connection is not always available. Obviously, the light is a very simple use case, and you can solve that in many different ways, just by putting a light switch in. But think about some of the other things that we're building into this modern connected world, and you start to realize that something needs to change. So what do we mean in reality? Well, you can't always assume physical security, right? In the data center, there's generally an access control cage, and you don't need to do quite as many things as you would need to do on the modern day smartphone. So you think about the modern day smartphone, it's probably got a lot of the security attributes, a lot of the update attributes that you need for this kind of device. But also, it's quite a controlled environment. If you then think of the sort of data center services that you need to build into these modern edge services, you're merging the data center and mobile compute. But then you add in safety critical systems, and you basically have a data center on wheels with mobile security. It means that we're merging technologies from multiple segments. We're adding safety critical system requirements, along with mobile communication technology, mobile security. Sounds like fun. Sounds like the sort of thing that kind of challenge that we'd like to take up. So really, the move to fog is about latency, security, privacy, and autonomy when things go down. The picture says it all. But it also means that device creators, it does feel a bit weird calling a car a device, but I'm going to go with it, right? Because I do think of them all the same these days. But device creators can pick the right size, compute, storage, connectivity for the thing that they're building. Which means that anything to do with the fog has to be multi-architecture from the outset, right? No one architecture, no one vendor is going to win the fog space. Or at least that's my prediction. But it's also going to be truly open and scalable, because you're going to be moving services from inside the data center, much, much closer to the edge, running it on hardware that's not necessarily owned by the service vendor. So that means adopting standards for software, for platforms that we probably don't know about yet. Charles is smiling because that means he's in a job for life. So hopefully people have already been looking around at this, but if not, I'll do a little bit to introduce the Open Fog Consortium. This was founded back in November 2015, and as you can see, among others, Intel and ARM were founding members. That means Open Fog is multi-architecture right from the beginning. Now, I'm not saying this is the only consortium that's defining the fog. There are many standards bodies that are looking at this sort of thing, right? This is just an example. But it is really encouraging that right from the beginning, we've got multiple architectures involved in defining the solutions to this problem. Now, the Open Fog Consortium has defined a reference architecture which contains its 8 pillars of standardization. It's a unified framework to help software developers land their technology on these platforms. To develop compute, network, storage, control, accelerators, communications. I think network and communications are the same thing. Don't read the notes. Completely lost my thread now. In an open way so that you can move services between each of these devices. So interoperability is very key here. But it also creates a common language for us to discuss the different attributes that we expect from a fog node. So I'm going to look at a couple of these pillars. Always start with security. None of this makes sense if you don't have a security platform that you can trust. There are going to be gazillions of these things out in the field. So one of the basic tenets of security is updatability and being up to date. George mentioned this yesterday, right? There's very little point in saying that you're secure if you're running software that's 10 years old on devices that are trying to talk to other security critical devices. It means we need a standardized update mechanism, right? We've got to be able to update every single piece of software running on those devices. But it also means elongated maintenance periods for each of these devices. I've been saying this for a while. Expect maintenance to get worse. Imagine buying a car that within 4 years goes out of its maintenance period, no longer receiving updates with security flaws in it. That's not going to work. Consumers aren't going to do it. So smartphones, you see those getting updates for 4 or 5 years. It's going to be much worse the more complex these systems become. And let's face it, service providers aren't going to be deploying services to devices that they cannot trust. So one of the key attributes of security is trust. And one of the key attributes of trust, to me, is identity. You need to know what the device is that you're running on, and be sure that it is actually that device. But in the fog, there will be multiple devices talking to each other. Imagine the car in front is able to give you information about what's going on the road. If your car can't trust that it is actually what it says it is and where it says it is, you can't make use of the data. You have to discard it. So there's going to be a focus on actually defining what identity means and what trust means over the next few years. One of the big upsides of more local processing for me is privacy. I really do understand the convenience of these online services, these cloud services. I post on Facebook, I use all of the backup services I get with my smartphone. But I would also like to choose which services I opt into and what data is shared about me. I've got a connected car. I was recently quite surprised what the dealership knew about my driving style before I'd handed them the keys. They also knew exactly where the car had been and could tell me what speed I was going on my journey. And I don't remember signing anything. So I don't think the balance is quite right at the moment. I'd still like access to all that information. I'd like to understand what the car knows about me and whether I might use the accelerator a little bit too much and maybe I hit the brakes a little bit too hard. That's all very useful. I'm not sure anybody else needs to know. So I think privacy also gives you the move to fog also gives you a great opportunity to get some of our privacy back. Some of the IoT offerings that we've got at the moment are collecting wonderful amounts of data about our lives, but it's not necessarily held close enough to where that data is generated for my liking. Now, decentralized processing and control can enable multiple local nodes to handle the workload that you would expect to be handled in the data center. So if you can use multiple fog nodes within the network to do the processing of the data center, there needs to be a very open set of communication between the two. So open and scalability are very important pillars for me. It means the relationship between the nodes obviously must be underpinned by trust and security. So most of these pillars are interconnected. And then when you bring it all back together, you can see that they're defining a pretty comprehensive baseline for what you'd assume is required for this new emerging trend. So let's take a look at some examples. Video surveillance. So when you think of the amount of data being generated by HD cameras, streaming all of that data to a cloud service is not going to be cost effective, and there probably isn't enough bandwidth in the world to be able to do that on a city scale. So processing in the fog enables you to make local decisions about which data needs to be stored into the cloud. You can do smart things like, image detection, pattern detection, using local processing nodes before you need to move any data up into the cloud. So they can intelligently partition local processing and cloud storage. But also, imagine drones being controlled by a central control office. It's not going to scale. You've got a lot of latency in there when trying to control tricky things like takeoff, landing, loading and unloading. Although I quite like the idea of parachutes and just drop the stuff. So you can support autonomous awareness and very, very fine-grained control just by moving the processing closer to where the drones are actually operating. I couldn't really address this audience without putting something up about beer making. Manufacturing. So any factory, there are going to be industrial secrets being exposed by the IoT devices that are monitoring all of the attributes of that manufacturing plant. One example here is craft beer making. Yes. I thought the audience had been a bit too quiet. That's obviously the fog from last night. So the fog can enable lots of systems that have been installed over many years to be connected up and monitored by local servers. You don't necessarily need to upgrade the whole factory to give you the very real-time data on what's going on inside your manufacturing plant. But you can also use it to protect the data about what you're generating, do local encryption, and do some kind of local processing to minimize the amount of data that you have to share. And that brings me on to another example. So I've been talking to a company called Swim for over a year now, I guess. These guys have realized that to make smart cities, for example, because they work across multiple segments, to make those smart cities work, it's actually not cost effective to connect every sensor directly into the cloud. The simple cost of transmitting all of this data over telephony networks just makes the cost prohibitive. So they're using small-scale processing units to turn the data into stateful transactions. So that, for example, when traffic lights change or when traffic sensors detect that there are a queue of vehicles, they can use a local mesh to actually indicate into the cloud service that, that a state has changed. So turning this gray sensor data, where you don't really understand what it is, locally into something that's meaningful to the service that's being provided. And that's all based on fog technology, and it's being deployed now. So there always should be a so what slide in anything. Moving services closer to the edge means that we're going to be distributing compute. Rather than necessarily concentrating it in the data center, the compute is going to be anywhere you can imagine on your network. It means different shapes and sizes. The reason why I'm interested in that is that's what the ARM partnership does. We make compute of different shapes and sizes, different power levels. It's bewildering, the kind of form factors that we work on. It also implies more security. We've got the mobile security model. We're molding it with the data center model. We need to bring these two things together and define what that actually means to give us the right level of trust and identity. And it means interoperability on a scale that we've never seen before. So that means new runtimes, new communications protocols potentially, or just making sure that the ones that we've got are actually fit for purpose and secure. It also means new levels of trust. If service providers are going to start moving cloud services onto pieces of hardware that they don't actually own, that's another level of trust that we've not seen. Standards are going to be really key to this. Security is key. I believe having really good upstream support for the hardware is going to be key, because you're going to need to be constantly updating the devices that are running within the fog. And I think that's what George said yesterday as well. To me, fog brings together the best of all of the segments and all of the challenges of all of the segments, right? It's not all upside. Some of the problems that we need to solve for probably one of the hardest problems, like the autonomous vehicle, are going to be hard. But once we get there, the possibilities are endless. It requires us to work together to make sure those data center technologies can be delivered on top of things like mobile security and automotive safety criticality. It means working together on standards. I'm not trying to give you more work, Charles, but it is what it is. And standards that work on any hardware topology, any architecture. It's got to be truly inclusive. I thought I'd put a Lenaro slide in here. Because let's face it, a lot of the players that are going to be working on fog technology are already on the left-hand side. And actually, quite a few of the components that are going to be important to fog technology are already on the right-hand side. What we now need to start thinking about is how we merge some of these components, how we build on top of them to deliver the next fog experience. I couldn't do one of these without putting the robot picture up. It's like my pot of M&Ms. This is my call to action. What I'd like to see is that we all get engaged on what the next disruption is. I really believe that systems of connected embedded devices are the next big disruption, right? We've been through many waves of this. This is the next one that I think is going to hit us. So please, think about edge computing, fog computing, and where you fit in. I've raised this at the TSC. You've probably seen some of the conversations that George and Dave have been having. I want to see how us, as a Lenaro membership and the wider ARM partnership, play in this new space. Covers everything as far as I can tell. This is the new thing that everybody will be talking about. And thankfully, that's it from me.
Okay. Thanks, Mark. Here we go. And he did break a leg. All right, so please